Okay, so we're back on this file 3C, hack day 1, basics of Python, and we've run everything before this point, data manipulation with Pandas. We're going to be working with the city temperatures dataset. So I uploaded it using this upload, clicked on my day 3 folder, and then the city temperature dataset. Takes a little bit of time to upload to this server on Google Colab, but I've read it in, so I'm just going to hit play. That's going to load in the data and hit data.head, and I'm going to see all of these first few rows of that data set. Now, I've got it commented out here, but I actually do want a description of what's going on. So I'm going to hit data describe and see what's going on. Now, you probably see the reason that it's commented out. Data.describe looks at all the numerical information in the data and then summarizes what's going on there. It doesn't look at region or country or state or city because those are numbers, so it can't do the mean or the average of those. Okay, but it can look at months, it could look at days and years, what the average temperature is on average, how many there are, the mean or the average of all of the average temperatures, so add them all up, all the average temperatures recorded for each day, for each city, for each country, and then divide by how many there are, and the average temperature in Fahrenheit across the world was 56 degrees Fahrenheit. It's not an overly useful or informative number, but it's done that anyway. And it's come up with all these different measures about what the minimum, the maximum, and the spread in between is. Okay, that's not massively useful here, so I'm just going to comment that back out and read it so it gets out of the way. Now, like Besha was talking about earlier, we need to do a check to see if there's any columns that have no values in there. So we need to check each of these. So are there any ones that have no numerical values in for average temperature, year, day, month, and city? Any suggestions as to why state doesn't has lots of non-numerical values or not useful values?
Is it because the state is too narrow, or it's not going to give us a good result, is it?
In lots of cases, places just aren't in states. The states are particularly specific to China and to the US of A in this case. Every other country just has what's the region, what's the country, and what's the city. So Algeria doesn't have states. NaN, yeah, stands for not a number. Perfect, Chidindu, thank you. So we've asked it, are there any that aren't a number in particular or any useful value, and state is true. So we know that all the rest of them are full of actual values and numbers that we can use. So that's a good sanity check first. Let's have a look at all of the unique regions that there are. And this, again, we're down to useful things that Python can do quite quickly. So the unique regions or areas. So Deborah, state is returning true because only the USA and China have states in this data set. Everywhere else just has country and city listed. So the state, the value in state for Algiers and Algeria is just not a number, i.e. it's just blank. And if it's blank, we want to ignore it. So what are the unique regions of the world according to this data set? So we've got Africa, Asia, Australia, South Pacific, Europe, Middle East, North America, South, Central America, and Caribbean. So we've got these distinct regions that it's all broken down into. Okay, and that's going to be important for your activity that you're going to get on with. Alex, got a question?
Something maybe I didn't follow through, but if state is not available, if it's NaN, I thought it should be false, while others are true, is it?
So we asked it, are any of them not a number? So the rest of them are false because they are numbers or values that we can use, whereas state is just has values that we can't use.
Okay, I get
For
it.
this check, it doesn't matter whether it's text or numbers. It's if it's not text and not numbers, if it's not a number or an error code or something, then that's going to do that check. Now, the first thing I'm going to show you is how you can do a function, a mathematical function, and Bessie was showing you this operation earlier on, actually, about converting from Fahrenheit to Celsius. Like to think of myself as a modern and young man. I don't work in Fahrenheit, and I really struggle with understanding temperatures like that. So I'm just going to round these into Celsius values. So we've got a really easy way of applying a function to every single row of our data set, because remember, we've got almost 3 million rows like this, and we just need to change this average temperature from Fahrenheit to Celsius. And the formula to change from Fahrenheit to Celsius, if x is your, or if rho is your Fahrenheit value, you just do rho minus 32 times by 5/9, and that's just the conversion between Fahrenheit and Celsius. So we've got a function here that I've created. So all that's going to say is, if you give me a row, I'm going to convert the Fahrenheit to Celsius, and I'm going to give you that back. So I've created that function. Think of it like a conveyor belt. My conveyor belt now takes in Fahrenheit values and turns them out to Celsius values. The way that we use that conveyor belt with all of our data is that we just say the average temperature of the data goes through that conveyor belt. So it's equal to average temperature dot apply. So put it through the conveyor belt, and the conveyor belt function is called to Celsius, this here. So that applies. Now, perfect question, Fika. What does the 1 mean? We're rounding this. So because we're times by 5/9, that's a fraction. It's got lots of decimal points. I want some accuracy at the decimal point level. I don't need a lot. So I'm going to do everything to 1 decimal place when it's in Celsius. I don't need it any more accurate than that, really. It starts off at 1 decimal place in Fahrenheit, so that's a fair thing to keep it to 1 decimal place in Celsius. Any more than that, I don't care if it's 4.72 or 4.73, but if it's 4.7, that is useful. Okay, so let's apply that, and that's going to apply that to the 3 million rows, and it took 2 seconds to finish the job. I mean, this is part of why Python is so powerful. So now if we look out at the head of our data, or the top bit of our data, we've got for Algiers, we're now in Celsius. So the 64 degrees Fahrenheit is just 17.9 degrees Celsius. So hopefully for you and for me, it's a bit easier to understand the temperature range that we're working with. Now we're going to look at just some standard things that you can do. And I'm going to zoom and focus in on an individual city in a second. So what we're going to do is I want a summary by region, country, state, city, and year. And you can do this, which is really quite clever. You'd have to do pivot tables and all that other jazz in Excel to try and get this and design it that way. Or you can just say group the data by these things. So it's focusing on North America. There are 4,000 rows here, so there's a lot, but it's just printing out the average temperature for each year in a particular city in whatever state that's in the US and in North America that it's focusing on. Okay, because I think it must just be the US that's got states. So because it's got states, it's grouping by those. Everywhere else doesn't have states, so it can't group by state. But we see that for San Juan, Puerto Rico, which is US additional territories, it's listed as, the average temperature for 1995 was 27 degrees C. For 1996, it was minus 15 degrees C. For 1997, it was 15 degrees C. For 1998, it was 11 degrees C. When you look at the variation in that, that's quite something. And this is what I'm thinking when I'm going through the data and doing all this exploratory stuff. Does it make sense? Or is there more investigation than we need to do to see what on earth is going on? I would not expect a city to be 27 degrees C one year in 1995 and then minus 15 the next year. You're right on the money there, Gavin. Detecting outliers. What is pulling that temperature down? How are we going to find that? Okay, and likewise, it made it jump back up 30 degrees C the other way in 1997, not quite to the original temperature. So let's go ahead and find out. Okay, what we're going to do, instead of looking at these cities and things, that's all fine, but we're going to focus on a different city, Vienna. So I'm going to get the data out from my data frame called data, and I'm just going to leave it all data, and I'm going to pull out just the information for Vienna. I want to leave it in the original data frame, so I'm just going to copy it. So in much the same way that you might just highlight cells in Excel and copy and paste somewhere, this is doing a copy and paste in essence. So Vienna is the information from the data where the city is equal to Vienna. And if you haven't been, it is a great city. So I'm going to comment these out and just run that first of all. Okay, let's do Vienna.head. In fact, we'll do Vienna.tail. We've done heads lots, so let's look at the tail end of Vienna, and then we'll see what's going on. So Vienna, you know, has a lot of rows, information in there. It's in Europe. The country is Austria. The city is Vienna, so it's pulled out the right city for us. That's good. The last recordings information was for May 13th, 2020. And the average temperature was 6 degrees then for that day. On the 12th of May, it was 8.5. On the 11th of May, it was 16.9. 10th of May, it was 18.7. So we're getting to see what was going on in Vienna then. So I want a summary though by year of what's happening in Vienna. Let's take a look. So I'm going to say Vienna, I want to group the information by the year and then just look at the average temperatures or the mean of those average temperatures per year. I'm going to print out Vienna this time. Okay, so it doesn't look as nice as the head, but it prints out more information. Deborah, so great question. So if you do head, it gives you the first 5 rows, top 5 rows. If you go tail, you get the bottom 5 rows. I just swap between them every now and then because I think if I'm always showing you the head, then you never get an appreciation for what's happening in the tail. And it will be informative as to why I did that in a minute. So we've printed out Vienna. So the average temperatures in Vienna from 1995 all the way up to 2019 are all listed here. You're right, Gavin. Yeah, exactly how the top 10 function in SQL. Fika, I added .copy because if you don't add .copy, then it's not doing a direct copy of the information. In the same way that you want to copy and paste rather than cut and paste or delete or any stuff like that, or edit it inside the data frame. You want to copy it out of that. So when you're doing this data set, any city that you're working with, copy it from the data frame just like this. Just change what city you're looking at, and then you can work from there. So we could see the average daily temperatures working along here. Now, the month and the day columns here don't mean anything. Oh, perfect, Alex. Yep, I've jumped in and I haven't even introduced that. And we're going to do that a lot because there's some things that's just subsumed as part of like computing, and some things that we wait and see that either everyone's comfortable with or we don't know, or they might not be. So equals is when you're saying x equals 3. Double equals means is equal to. So here I'm saying I only want the city, the rows from my data, where the city is equal to Vienna. If I didn't do that, then it would change every city in the data frame to being equal to Vienna. I don't want that. I just want to say I only want the rows where it is equal to Vienna. So if I just, oh, I didn't want a text. There we go, code. delete those. So let's just throw this x equals 3. So x is 3, and I've set that up. If I print x, it prints out 3. Print x is equal to 3, that's true, because this is doing a logical check. It's saying, is x equal to 3? Yes, true. Return that. If I change this to 4, then it prints out false. Okay, so this is a logical check, and this is an actual just setting the value of x to being a specific value. So this logical check is saying only get the rows where city is Vienna. Does that make sense? Okay. The nice thing is that you can take these through 4 lines of code and just change around the city and get the same information out. And you're not on your own by any means. I'll explain how you're not on your own later. Now, why do we think month and day look like this? They're always about the same for each year. That seems a bit weird. So this line of code here, so I got the information in that Vienna table, and I've just said, do the average of all of that. The average day, when your days go from 1 to 31, or 30, or 28 for February, or 29 for February in a leap year. So the average number of days in a month is 15.72. The average day number is 15.72. It's the middle, in essence. So that's the average day for each year. And the average month, because there are 12 months in the year, is 6.5. So if you add up the numbers from 1 to 12. Okay. So those aren't informative bits of information, month and day there. So we're just going to drop those from our information and then just look at the head of our new Vienna. So I'm going to get rid of this print statement now. So if I just look at the head now, we got rid of or dropped month and head, day. Now we can just look at the head or the top 5 values. So we can see 1995, 6, 7, 8, 9. We can see the average temperatures there. And that looks about right. From my limited knowledge of the temperature profile of Vienna. Now, it's all very well chucking data out and things, but actually I think we need to dig further into, and we need to explore it visually. And this is going to be an important thing that I want you to do and focus on, really. You can do some of the machine learning things that Besh has taught you, or that Luke's taught you and showed you, and that we've done before. You can do some of the statistical summary things that I've shown you, but what you're going to get the most value from for this hack, I think, is by doing the visual analysis. So using some of the charts and plots that Aisha introduced earlier, and think about how you tell a story about this data set. So I'm going to plot the information about Vienna for each year and the average temperature. I'm also going to add a straight line to it. And I've used this function here, polyfit, to fit a straight line. So it's mx plus b, or ax plus b if you're more comfortable with that, where I've got the straight line of the relationship as time goes on between year and average temperature. So by looking at this, we can see that the average temperature is on an increasing slope over time, which fits with all the scientific tales and what we're seeing in our temperature profiles across the world internationally, except for the fact that 2020 is a really low value comparatively. So again, thinking with our data hats on, what's gone on in 2020 to make it really low temperatures compared to every other year before that in our data set? Yet, Gavin, it's a perfectly linear trend, straight line up. Okay, straight lines are fine in the short term. We're getting a bit of an idea what's going on. generally your data is a bit more complex and needs something a bit more intricate, or you know, some deep learning, for instance, or some of the more advanced methods that Besher was hinting to. So we've got a problem because 2020 is really low in temperature. So we need to explore and understand why. So let's have a look at the tail of Vienna. We've got average temperature is 7 compared to 11 and 10 for the previous years. So it was jumping up, and then sudden drop. Why was there a sudden drop in 2020, do we think? It'll become clear in a second when we look at this. Now I'm going to explain my code first of all here, because although it looks like there's lots of lines of code, actually there's just 3 lines of code that I've just copied and pasted and changed the year. I need to know what's gone on in 2020, and to do that I need to have a comparison to history. So I need to plot historic data and then 2020 and get an idea of what the difference is. So I'm going to plot the data for 2020. So in order to do that, I'm going to get the data out from the data frame where the year is 2020 and then plot. So that's this line. Then I'm going to get the data out that's from 2019 and plot. Then I'm going to get the data that's Vienna, get the 2018 data and then plot. So I'll just put comments in there. So get 2020 data for Vienna, plot. Get 2019 data for Vienna, plot. Get 2018 data for Vienna and plot. Oh, top points for Anastasia. Okay, let's see if you're right. We've got 2018 in green, 2019 in orange, and 2020 in blue. So Anastasia seems to think that we've only got the winter data for 2020. We haven't got the summer data. Looks like we've got a lot less data. Do we think she's right? And yeah, Gavin, you noticed that earlier. When we looked at the month, the average month, it's only 2, so actually 2.7. So we only have a few months worth of data for 2020 compared to 2019 and 2018. If we're missing all the summer months, we're going to miss that much higher temperatures. The average is going to be less. So we need to be mindful that any analysis we do on 2020 doesn't have complete data. So if we're going to be analysing on a year-by-year basis, we have to stop at the end of 2019. So that's our first thing that we've done. But this... Good question, Alex. Python, if you just keep adding things to a plot, it generally changes the colour so that you can see the difference between them. It's an automatic thing. So here, because I'm just adding to the plot, adding to the plot, adding to the plot. And if you kept on adding, it would keep changing the colour. I think it cycles round after about 10 colours. Can't remember the exact number. Can anyone see a problem with this plot though? Because we've answered one question of what's gone on in 2020, but by exploring our data set, we've given ourselves another question. What's wrong here? Zoom in slightly. We'll look at the 2018 and 2019 data. Do we really think that it was minus 72 degrees suddenly in 2018 in January or in November? You're right, Mary. No, it wasn't suddenly minus 72 degrees. Yeah, And that's why we need to get the data in front of us in a plot so that we can do that, so that we can see what's going on and our brain goes, whoa, that's weird, let's go and investigate. So what we can do is have a look at the, now sliced is our 2018 set of data. Okay, if I hover over it, it'll tell me it's a data frame with 365 days and 8 columns. So 365 days is just 1 year and it's just 2018 data. So we're focusing now on Vienna for 2018 because we just want to look at an individual slice and understand what's going on there and create a pipeline, and then we can go from there. So let's first of all check if any of them are empty or is null, if any of them are not numbers or NaNs, and then how many are less than -20, because maybe they had a really cold day, but it was never quite -20 in Vienna. So any values less than this, I want to know exactly where they are, and then we can see what they are and why. So there weren't any empty values. There weren't any not a numbers or nans, or like those states were for lots of the places. For Algiers and, you know, for Vienna it would be the same. State would be not a number, NaN. So that wasn't the case. But there were 3 low values in 2018. So it must be 1, 2, and 3. You know, because there's 365 days worth of data here, a couple of them are probably bundled together. So let's look into them and find out what index they're at, what row in our data set they are. So their index is 641,048, 641,362, 641,363. Let's just have a look at those values there. So that would be, and we're just printing them out here, the data or the data at location of each of these 3, where it's less than -20. And remember, you will have all of this, so all you need to do is to change around where it says Vienna to find where it's less than -20, if there's any missing data in the city that you choose to work on, and then to print out what's going on there to rectify that problem, because these are bringing down the average temperature for the city of Vienna. Okay, it's artificially changing our analysis, so we need to deal with that, because it wasn't -72.8, and -72.8 happens to be the Celsius equivalent of -99 Fahrenheit. So they just put a -99 in when they didn't have any data. Whether the measurement system broke, the computer had an error, something went wrong. So it's for Vienna, and the 4th of January in 2018, the average temperature was listed as -72.8. Now, we have 2 options here. Okay, if you were outside of AI and computing and regions, then you would have one option generally. You would just delete the bad data. And in lots of cases, that might be the right thing to do. But if you've got lots of bad data in a really, you know, serious life-threatening environment, you can't just say, oh, we had bad data, we couldn't do anything about it. Okay, when I was working with the children's hospital, I couldn't turn around to the doctors and say, I had no data. Sorry, I can't tell you if that patient's going to get worse or better anymore. Just missing data. No, it happens. You know, that wouldn't have been acceptable. And it's just not in any environment that I want to train you guys ready to be for. So you can either cut it from the data frame and delete it, or you can fill it in, because we know it's bad data, but we can work out, roughly speaking, what it probably should have been, the temperature for those days. Because we know that the temperature is following a quite reasonable trend over time. Yeah, a load of up and down shapes. Now, depending on what background you're from, you'll see different shapes here. Okay. If you're not mathematical and don't have that strong background, you might just be seeing a TP shape or a triangle. In essence, so it's just up and down, up and down, up and down. If you're from an engineering or construction background, you might see sinusoidal movements. So these curves and waves and things that go up and down periodically like that. If you're from a more mathematical background, you might see quadratic equations, all those things that you learned about in secondary school, y equals x squared and things like that. So what we're going to do, I'm going to show you how to do 2 ways of filling in the gaps and 1 way of just how to delete it. And it's up to you when you're working with this data, if you find missing values or bad data like that, whether you want to just delete it or fill in the gaps. So all you have to do to delete a row from a table in Python is just drop sliced. So the table is the table where I've dropped row 641,048. So this one. So let's run that. Now, I've dealt with that one. So I've got 2 left to deal with. Okay, and we're not going to delete these ones. I'm going to show you how to fill them in. So I'm going to print what's going on either side of that. So let's have a look at that first of all. The 2 missing values happened together on the 14th and the 15th of November. So probably some of the measurement equipment broke or the computer system broke and they just couldn't record it for those 2 days. So we can fill those in one of 2 ways, quite simply. There are much more complicated ways of doing it, and there are some really simple ways of doing it. Often, simple is fine for just a small amount of data. So I'm going to look at column number 641,362. So that's this first missing one. And for this one, I'm going to say that the temperature on the 14th of November should be the temperature from the 13th plus the temperature from the 16th divided by 2. So the mean of those 2 temperatures, just the average. You could go for more, you could go for, you know, a lot more if you really wanted to, but I'm just going to add those 2 values together and then divide by 2. So now if I look, I've filled in that value that was minus 72 there. I've now filled it in, and it's now saying that the temperature on that day was 6.05 degrees centigrade. Okay. So that seems reasonable. It was 7 a couple of days ago, then 9, then I'm saying it was 6, then I've got no information, then it was 2. So it's coming down from 9. In the ballpark, that seems like a reasonable temperature. So that's one way of doing it, taking 2 values, one before, one afterwards, averaging them or dividing by 2, and then setting that value. Or we can look at the data beforehand and saying it's probably the middle value for the last few days. So I'm going to say this time it's just the row that's missing data, this 363 here, is the data right up until beforehand, so from here and for the last 10 days, and then just do the median or the middle value from those. Now if I print it out, we see that we're saying here's our temperatures, and these 2 in particular are the ones that I've just filled in. So 6 for one day, 9 for another, and then drop to 2, then minus 1. Entirely believable data. Oh, sorry, yeah, again, thank you for having me to count there, Figure. Yeah, so sliced dot at means just, easiest way of explaining this is I'm going to update the value, average temperature, at index 641,363 to be whatever's on this side. And if I just cut that and just said 100 and did like that, I could run that, and then if I print that out again, then it changes it to be 100. So what it's doing is updating the value, average temperature at that location to being whatever is on this side of the equals. So I'll put that back in, rerun it, and then we've got that happening there. So it's just our data slice, and we're just updating that slice of the data to fill in those bad values. Does that make sense? Off the top of my head, I don't know. Let's have a look. It creates a new row in the data frame. So what I'm going to do is just undo that by just running everything beforehand again. So you need to use sliced.app to do it at that particular row. Otherwise, it will just try and create a new column. So if I reprint it, there we go, we're working. So 2018 is now fixed. We deleted one row of bad data. We filled in one with the median and one with the mean. So we're going to plot the data. I'm going to say what the maximum temperature and the minimum temperature is. And remember, we can do max for maximum, min for minimum, and just get, because of the way that Python works, it'll do that for us and just pin them straight out. So that's what 2018 temperatures look like. Maximum was 27 degrees, minimum was -10. Okay, and it follows a nice standard temperature profile. That is 2018 fixed, and that's all the analysis that I'm going to show you how to do with this data for Vienna. So the main thing, and the reason that I've used sliced here instead of Vienna, is because everything after specifying Vienna is just based on this sliced variable. So you can change around the city and everything else should still work. So you change it from Vienna to Paris or to London, for instance, or Lagos. You could change to any of those, get those temperatures out. You'll have to find the specific rows where you've got bad data, these three, and then change that into these and change the right rows into all of these things. If you're more comfortable with the programming, you can automate that part and set those as variables. But if you're not, don't worry, you can just get it to print out where it's got bad data and then change these. So you should all, by running this, you should all first of all just be able to rerun this and then get the information for Vienna, and then be able to just change Vienna for somewhere else. Okay. Now we're coming on to the actual hack activity. You've got this far. You've got this data set of city temperatures. So the activity that I want you to do in your groups, and you've all been allocated to groups now and have your own Teams link for a group. So there are 10 groups where there's multiple people in each group. And I've allocated everyone who's signed up for this hack. Some people aren't going to be attending through work commitments and things, but they wanted to sign up to make sure that they got access to the recordings or to register their interest. And some people have been attending for the last couple of days and aren't going to be available tomorrow or Friday, for instance. But everyone's been allocated into groups. Now, after I finished it, as a group, I'd like to join that link that I've sent you for your group, whatever number, group 1, group 5, group 10, Hackathon, Teams link. Okay, join that, and then as a group, decide on a research question or something that you'd like to test. Okay. Now, it could be you want to test whether or not the average temperature is increasing in a specific city or a group of cities, or if you want to check if the average temperature is rising as quickly in some cities as it is in others. For instance, are temperatures rising in the capital cities in Europe as quickly as they're rising in South America and the Caribbean, or in Africa? What's the temperature profile like of Russia? Have the minimum and maximum values moved further apart? Are we seeing more extreme weather over time? And you've got this data from 1995 all the way up until 2019 for loads of cities. You've got loads of rows, so you can come up with quite some intricate ideas for what you want to do. You could, if you wanted to, take the data and try and predict future temperature values and come up with a predictive model. It's entirely up to you as a group, so decide on, broadly speaking, what area you want to work on, and have the data open, have a little flick through, have a think about what might be interesting for you. And you can answer more than one question, but try and answer it well and be able to explain what you're doing. And the way that you'd explain it is by getting statistics and information out, so like the minimum, the maximum, the average temperatures. Maybe you want to do some fits to the data, like the linear fits, or you could do a quadratic fit to the data. And if you're interested in that, we could show you how to do that, but that's by changing this number 1 here. So you could do more complicated things. Some of you have got a computing background, maybe able to do more advanced techniques and things, and that's fine. But make sure you fill it with plots as well. what I would like from you as a team then is a set of 6 PowerPoint slides. And I need these submitting by 11 AM on Friday. 6 PowerPoint slides. 1 to introduce your research question as like a title slide, and to list all team members who contributed in any way, shape or form to the project. And then 5 slides at most to say more detail about the research question, what cities you're focusing on, what you found, what your recommendations or your future ideas are. Almost think of it like a project proposal with a bit of data analysis. So it's open to you what research question you want to ask is as a team. You can focus on whatever cities and things that you want to, and do comparisons. And you can go off in small, mini groups, and you could say, right, a couple of us are going to work on this city and get the information, the plots, the data out. A couple of us are going to work on that city or this city, and we're each going to go and analyze an individual city, do the same thing, come back together and say, oh, do you know what? Russia's look like, Moscow looks like this, but London looks like that, but this, and come up with a way to try and tell that story in the slides. So you're all being allocated to these groups, and you can start as soon as I've finished, and you can join those Teams calls and start brainstorming what the research question will be. I'll be available if you want to drop a message in this channel, and I'll try and respond to those, although we'll all have left this channel to go onto all your individual teams. Throughout the day tomorrow between 10 AM and 4 PM, Hamayoun and Doa are going to be available and dropping into your Teams calls one by one, and they'll cycle through those to spend about 10-15 minutes at a time to come and first of all see if you've got any questions, support you, help you with the research aspect and with the code if you're struggling at all throughout the day. And also feel free to ask them any questions about life at BCU, given that they both studied the MSc AI in 2021. Right, so ask them how it was, for them, what advice they have, get the inside information from them. Completely any questions that you've got, they're going to try their best to openly and honestly answer those. So you can ask them all. They're going to support you, and then Friday morning, 11 o'clock at the latest, I need your set of slides emailing into me. 2 o'clock in the afternoon, we'll join back together on Friday. So you'll have, Friday 11 o'clock is when it's due in. Then there's a session from Luke on AI ethics. Then in the afternoon at 2 PM, we'll join back together, and there'll be an announcement of the winners, and the executive dean for our School of Computing and the Built Environment, Professor Hanifa Shah, is going to be presenting or announcing the winners of the competition. The winning team, who then the members of that who come on to study the MSc AI, will be registered and have the opportunity for doing an industrial internship in semester 2. So after you've learned those computing foundations and machine learning background, you'll be doing an industrial project while studying the modules of semester 2, but we'll fit it around that so that you get that hardcore data science experience there that's going to be really valuable for CVs and things. So to do on Thursday, tomorrow, Hamayoun and Doa are going to be joining the calls that you've got, the Teams calls, where I've sent those all out to you, your groups. They'll be joining those Teams calls to then see if you've got any questions, and then you can ask them about, studying on the MSc AI. So, is everyone clear on what I'm asking you to do for the hack? As I say, any questions about that, you can just pop them in this channel, in this chat, and I will respond to those. I'm just going to go through what, because there's been some questions first of all, so I'm just going back. Okay, so I did the slide start. We've got the difference between that. We'll start with Aditya. Okay, can we look up and plot the data of multiple cities at once? You can do with different sliced variables, or you can so try it out and see how far you get. And Hamayoun and Doa will be able to help you with that tomorrow if you get stuck, or another group member will. Could we take the intercept and slope and look at all data points and add seasonality index and then predict bad data? You certainly could, Gavin, but even if you clean the bad data out and then look at the intercept and the slope of this data of this here, similar cities will have a similar intercept and a similar slope. But what might be interesting to see is ignoring what the intercept is, because hotter countries will have a higher intercept, but if the slope is similar for hot countries or cold countries, or if hot countries are getting hotter at a quicker rate. Okay, how do you connect with your group, Sahik? So I've emailed and invited everyone to given them a meeting invitation that started at 2 o'clock today and finishes at 11 a.m. on Friday. So you just click to join that link. Iain, could you please note it down? What are the 6 content? I'm not sure I understand the question there, Prachi, about the...
Iain, what we have to do for the PowerPoint slides? Like, I'm not understanding it.
Okay, one slide is a title that has your main research question that you're trying to answer, like, are countries in South America getting hotter every year than in Europe, for instance? So the research question and all the names of everyone that contributes. So that's slide 1. And the other 5 slides are just explaining your research question and why you're asking it. So if you're from multiple countries and say, we wanted to assess that for our own countries, or we wanted to investigate this because ... And you can be personal about that, and there's nothing wrong with a personal motivation for a project. Then some plots, some visualizations, and some statistics or data to justify whether or not you're, based on your research question, is it getting hotter? And you're saying, yes, it is getting hotter on average. I'm not going to just take your word for it. You need to show me with the data. So get the maximum and the minimum values and plot those over time. And we'll see that getting hotter and getting colder each year as well. Is it getting more extreme or less extreme? So whatever your question is, whatever analysis you do, just make sure you've got plots and you've got data and numbers and statistics coming out to prove those, whether or not that's true.
And what is the topic? Like, we have to find out the different temperatures of the countries, right?
So you can find out whether you can look at the average temperature for each year, or the minimum or the maximum. You can pick different cities. You can dig really deep into just one city over time. But there's lots of scope based on everything we've talked about so far in this hack. You can do lots of different things there. And I think it might be best if you go away with your group, actually, and then see what ideas people have for what questions they want to ask. And I'll be available in this chat here. So if you wanted to ask, can we do this? Can we do that? Etc. Just drop me a message and I'll be more than happy to say, of course.
And we do have to code as well.
So you've got a group to call in, yes. So you can talk to each other on that Teams channel throughout tomorrow. Like from today,
Okay.
you can decide on the research question today and the rest of our time. And then tomorrow you can work on it throughout all the day. And then it expires at Friday morning at 11.
Okay. Got it. Thank you.
Perfect. Alex, print minimum is recognized that instead of minimum. So, and we're starting to see why my code never works first time normally. So that should be minimum, but it's not a variable. I didn't set it up, so it's in quotation marks. Whether it's singles or doubles, it doesn't matter for Python, but it's a quotation mark. So I'm just asking it to print something. So it could even say, hi Alex, we'll change it to the minimum is. So it doesn't matter about the whether that's minimum or minimum or whatever, but what needs to be right is where you're working with any variables or things. So if I put man here, then it's not going to work. See, it's throwing up a load of errors. So that needs to be .min to be the right operation there. Thank you very much, Alex, for suitably summarizing what I've said there. In terms of the slides.
A quick one.
Yep.
Just a quick one. So after the minimum, you just add the is it apostrophe? They say one single apostrophe.
Yeah.
How are you able to get a result without having to?
So Python treats singles and doubles the same.
Oh, I see. Just from where Alex starts from.
Yeah, just from wherever it starts from. Okay,
Despite the fact that you were having space.
Yeah, if I take this out, it's going to break because it has to open and close the singles or doubles, and it has to be the same one as well, I think. So it has a single has to be closed with a single.
So what's the role of that space then? I think it's only the space that is confusing me.
Oh, the space.
Yes.
Okay, so that's just my own unique way of formatting. So it prints an actual space there. So sometimes, depending on what you're printing or what you're doing, and you can print lots of things out all in one go. So let me join. If I just do a quick edit, and if we get a little bit more advanced, but I think it should be clear. We don't have to print them on separate lines. If I do that, you'll see that it's got a single space here after the minimum, and then before this which is cold starts. But I wanted to have an extra space there at the end, and I normally like that. And sometimes the things I'm working with just print without a space, so it just prints right next to the semicolon. Therefore,
it can be without space.
Yeah.
Oh, thank you.
Yeah, Gavin, so I'll be saving this and uploading to YouTube. YouTube's being a bit slow with processing at the moment, so when it renders the standard definition and the high definition version of our talk, so it might take an hour for it to actually be ready and clickable and visible, but I'm uploading as soon as I can for them. So Raphael, yes, you can meet your team today, so you should all be ready to jump onto the call in a minute's time. Spaces, yeah. Okay, so it sounds like we're all on board with what we need to do for this hack. As I said, I'll be monitoring this chat, although I'll be off the camera and out of the call version. I'll be monitoring it just in case anyone's got any questions. Then Hamayun and Dara will be joining you tomorrow throughout the day and just dropping in as and when there's questions and things. So they'll be helping you periodically. And you can ask them anything about the course. And then we'll look forward to seeing it on Friday morning at 11. Good luck. Don't panic if you feel well out of your depth with doing any of this stuff. Just first of all, start by running through the code that we've got here. Hit play and run through it all, and then you'll have gotten most of the way there to being able to do your own investigation. The next thing is to just change around Vienna for another city that you want to do, and then start from there and think, what do I want to know about them? What would be an interesting thing to look at? So this is the file 3C, hack day 1 basics of Python, in the day 3 folder that I sent the link out for last night. Aditya, that's a great point. Yes, I will download and share it now. Can I just add it to the chat? No, I can't just add it to the chat. I will download and share this now. I'm going to stop the recording there. So good luck.